Local legend has it that this lonely steam engine sitting out here on a street corner just outside of Holland, Michigan, once powered all the lights at the 1904 St. Louis World's Fair. But is that legend true? Let's find out.
There's a couple of really interesting features on this 350 horsepower Corliss steam engine that I haven't seen before. I also found an old insurance underwriting map that shows us a lot about exactly how this engine was used to power the factory, and honestly lots of other factories around the world too. First though, let's talk about the engine itself. It was built by Allis Chalmers in 1905. It weighs nearly 23 tons with a 15-foot, 5-meter flywheel, which alone weighs more than 8 tons. It has a single, double-acting cylinder with an 18-inch, 457-millimeter bore. It has a 42-inch, 1067-millimeter stroke, and operated at 85 RPM. One really interesting feature of this engine, which you can only see if you get out and walk around behind the engine, is this odd rod or tube attached to the crank here. If you've seen some of my other videos, you know that keeping these engines lubricated is a major challenge. Also, like me, you're probably mourning the total lack of oil cups and some of the other parts from this engine. But this part here is one that I've not actually ever seen before. This system is called a centrifugal crankpin lubricator or centrifugal crankpin oiler. It has several major components. First, the vertical red post is called the stand. Its job is just to hold the oil cup, which is now missing. The gray tube, called the feeding arm, is fixed rigidly to the crank assembly. That's the part we're trying to actually oil. It comes down from the crank arm to the exact center of the crank and ends in that hollow ball. Oil drips down from the now missing oil cup and just sort of slowly oozes along that thin horizontal red tube. When it reaches the end, it drips into the ball, which is spinning at 85 RPM. It's flung to the outside of the ball, finding its way into the gray tube, which is where the centrifugal force really kicks in. Moving outward along the gray tube, it speeds up so much that it doesn't really care all that much about gravity anymore. The oil is flung at high speed outward into the crank pin assembly, providing a continuous supply of oil, no matter what position the crank is in. It's really ingenious and an incredibly simple solution to the problem, as long as you get that tube into the exact precise center. Off-center, and it'll just rip the tube right off. So with the information we have so far, I'm afraid we've already dispensed with the World's Fair rumor, since the St. Louis World's Fair was held in 1904, the year before this engine was built. Here's the real connection. The owners of the Bush & Lane Piano Company, visiting the fair and already planning a new factory here in Holland, Michigan, saw the steam engines there and ordered this one to run their new expanded factory. Like all Corliss steam engines, it's designed to run incredibly smoothly and to resist sudden speed changes due to changes in load. When a saw bites into a heavy, massive oak log, for example, to cut it into planks for a piano, a Corliss engine would still maintain speed. That's especially important in many industries, including woodworking. If you happen to be doing the final polishing work on a piano at the other end of the factory, when that saw bites into the log, you could end up with what's called chatter marks or ripples on the wood. That'd force you to start the whole finishing process over again. This was a real risk in the belly room, which was the specialized upstairs workshop where all the fine-tuning of these instruments was done. Since they only wanted to run one single steam engine, they actually wanted a bit more insurance than that, though. That's why we have this really weird-looking flywheel with 12 separate channels called a grooved flywheel. Here's a smaller Corliss steam engine that I filmed the same day I filmed this one. It's located just north of here at the Muskegon Heritage Museum of Business and Industry, and interestingly enough, it also has its own World's Fair rumors. This one's actually running though, and as you're probably used to seeing, it runs with a huge leather belt. It's tough, it's durable, it works great, but it only provides a single drive system. You can check out my video on this engine, linked in the description. But now let's get back to Holland. The Bush and Lane Piano Company wanted their one steam engine to actually provide multiple semi-independent drive systems. So they actually used a different system that allowed them to run those independent systems from this single flywheel. Here's how it works. With one engine and one flywheel, you run separate ropes to multiple different pulleys. Each of those pulleys drives a completely separate system. Now you don't need to run just one rope, of course. For systems that need more power, like the heavy sawing and planing that they did at the piano factory, they might have run 3 or 4 ropes to that one pulley, which itself would have had grooves in it too. If you want to run a small dynamo or generator, just for electric light, maybe you just run 1 or 2 ropes for that. Adding to your flexibility, if you run those ropes from the flywheel to a big driven pulley, it'll make that system turn more slowly. If you run the ropes from the flywheel to a smaller driven pulley, on the other hand, that system will run much faster. Here's a picture of the one at Bramford Mill in England. You can see there's 2 ropes going to a higher system and 5 going to 1 or maybe 2 lower systems. But it's all driven by the same engine. There's no photos of the inside of the factory to show us exactly how they used this engine, but we do have a map produced by the Sanborn Map Company and used by insurance underwriters to tell us quite a lot, really. Sanborn produced maps like this and sold them in atlas form, largely to insurance companies. When you wanted fire insurance, the agent, who might be hundreds of miles away, could just pull out the atlas for that county, look at your site, and determine your rates, all without ever visiting the site. Here we see our steam engine located in a smaller, separate building away from the main building. This kept the heat and steam away from the piano wood, which was good for the pianos, and kept the fire risk isolated too, which was good for the building and, of course, the insurance rates. There's actually one other advantage too. While you saw what looked to be steel wire ropes or cables connecting the engine at Bramford Mill, that's not likely what they used here. Instead, they'd have probably used Manila hemp rope to connect from the main flywheel to each of the separate drive systems. Manila hemp, which isn't really hemp at all, is actually from the abaca plant, which is actually pretty closely related to banana plants. These tall plants, maybe 20 feet, 6 meters tall, are built exactly like the leeks which we eat, with no trunk at all since they're not trees. Instead, they're made of long, tightly overlapping leaves that are peeled away to harvest the fiber. The fiber from these plants is high in both lignin and cellulose and is naturally water resistant, which made it especially good for working around steam engines and in wet climates. Now these fibers and their ropes still tend to stretch when it got warmer or wetter, so they needed a way to tension the ropes. By using nice, long ropes, these main ones going into the building need to go around 40 to 65 feet or 12 to 20 meters. That means that the longest ropes, to get around the flywheel and pulleys, would have been around 110 to 170 feet or 34 to 52 meters long. They were spliced into themselves to form a long single loop. With the weight of the rope, gravity would pull them down, and that load would also pull the ropes tight into the sharp V-shaped grooves on the flywheel and the corresponding pulleys to ensure a good grip. Many of the ropes went from this small engine house overhead, likely through a sheltered insulated passage, into the main building to power everything there. Many, but not all. We'll come back to those. Once arriving at the main factory, the ropes were almost certainly split into 2 groups. One group that went around a large pulley to power the slower moving, heavy equipment like saws. The other group went around a much smaller pulley to power the fast moving equipment like finishing sanders and polishers. By splitting the ropes into 2 different systems, you not only had 2 mostly independent line drive systems running at very different speeds, you also had a huge 8-ton flywheel and the stretch of the long Manila hemp ropes acting like a giant shock absorber. You were still running only one engine, but it acted almost like you were running 2. But there were actually a couple more things that the engine did. Right in front of the engine was a dynamo to produce electricity. In 1905, municipal power wasn't all that available or reliable here in Holland, so they produced their own. The other thing you see here, right behind the pair of boilers, shown here as black rectangles, and in front of the big coal bunker, is the Shavings vault. This almost unreadable mess to the left of the boilers was the vacuum blower system for the factory. An extensive network of ducts spread throughout the factory to every saw, planer, sander, and workstation. Sawdust was automatically connected and drawn back here to the Shavings vault and blown into the furnace as free fuel. Of course, that high-power vacuum system needed a couple of ropes from the engine too, but it was a critical system to keep the fire risk down in the factory and to prevent sawdust in the air from ruining the finish on the pianos. I want to take a second to thank my Patreon and YouTube members who make it possible for me to come out and document and share our incredible heritage, helping to preserve it for the future. Members get monthly updates and insider videos to go behind the scenes of this work. You can join at patreon.com/industrialrevolution or here on YouTube. Thanks for your support. Now let's get back to the video. With the rise of radio in the mid to late 20s, piano sales were falling. Player pianos, with their paper music rolls, had been very popular, but free radio programs with full orchestras were just better. Finally, in 1929, Wall Street crashed and took high-end piano sales and the Bush & Lane Piano Company with it. The building sat idle for a few years until 1933, when Baker Furniture moved in. Since they had nearly identical requirements to Bush & Lane, and since reliable municipal electricity still wasn't available in Holland at the time, they kept using the engine. Reliable electricity finally arrived around 1940, but since their current system was doing everything they needed, and they got probably 60 to 75% of their energy free by burning wood scraps, shavings, and sawdust, the combination of costs and corporate inertia kept this engine running until 1959. With parts hard to find and the boilers approaching end of life, the steam engine was retired. They didn't scrap it though, as was so often done. Instead, as was also done pretty often, they simply abandoned it in the powerhouse. Well, they abandoned it for 8 years, that is, until 1967. With the creation of the Baker Furniture Museum a few miles away, and with the new owners, Magnavox, wanting to get rid of the old engine house and expand the main building, the engine, which had been well preserved, was moved to a pedestal in front of the newly created Baker Furniture Museum, where it sat until 1990. That's when the museum closed. The building's new owners, unwilling to keep the engine, were persuaded to donate it to the city of Holland. The city, having no plans for the engine, it again sat abandoned, this time until 2003. Local volunteers got the engine in 2003, restored it, and placed it on exhibit here, on a vacant city lot at the corner of Waverly and 32nd Street on the outskirts of Holland. Placed at this busy intersection, I'm sure you've seen people driving by in the background, today, this engine acts as an open-air museum, showcasing the region's industrial heritage.
So I love a good story, and the idea that this steam engine is the one that powered the World's Fair, that's a great story, but unfortunately, it's not true. This is a huge engine. I'm standing inside the flywheel. We have the eccentric here, the valve gear's way down there, and clearly this is a monster. But the fact is, this only provided about 1/14 of the power needed for the St. Louis World's Fair. So I wish it were true. It was actually built a year later. So the great thing about the old World's Fairs is that they really inspired people. They gave people hope for the future. They gave people incredible ideas. When the owner of the piano company went to the World's Fair and saw the steam engine, he was inspired to get one just like it, but scaled down just a little bit to actually fit, to meet the needs of his piano company, which turns out to be, like I said, 1/14 the size of what was used at the World's Fair. So, although this isn't in fact the World's Fair engine, it was inspired by it, the inspirations that happened at the World's Fairs, especially the older World's Fairs, were incredible and created things like this. And that's why the World's Fairs and this Corliss steam engine, these are the Industrial Revolution. Hey, thanks for watching. Hope you enjoyed it. If you could help out the channel, like, share, subscribe. Also, comment. I love reading the comments. I usually respond to them pretty quick. If you want to see more great steam engine videos, click on the playlist here, or the video up here that YouTube thinks you'll really enjoy next. Again, thanks for watching. I'll see you next time.